right side.
What right side and left side?
So the current
Okay, current is left
goes
side.
now. Current
Okay.
goes left to right.
You saw in that video, right?
Yes, sir.
You remember about that video? Ah, okay. So that's motion of that metallic plate now
Yeah.
that
Left.
can be understand using left hand, the three fingers of left
Yes.
hand.
Yeah. The thumb. So the motion goes right to left.
In that
Yes, sir.
video, what you said, that magnetic field was downward, right? Current was magnetic field was there and current was this way, or what? This was the magnetic field. I don't. It was the motion along this axis, the field directions. So it says basically, if this center finger is along the current, so current was the current was in this direction, okay, and magnetic field was upside down. So the thumb will show you the direction of force. That's the Maxwell rule. Clear? And what else we studied? This was the Maxwell, na? If current is in direction of this middle finger, okay, and field in direction of current, then thumb will show you the direction of motion. Clear? Or force. This was the Fleming rules. So what is, we studied about the induction. What is induction? We studied about electromagnetic induction, right? Can you answer what is induction?
So I don't remember.
Any of you? Jaslene? What is induction? And Faiz, why you are so silent? Jaslene, what is electromagnetic induction?
Sir, I'm not sure.
Okay. So you didn't study the textbook? So somewhere I remember maybe what is this? What is this? You
Let's
guys,
start with this.
so what is this? Do you remember anything? What this arrow means?
Moving off the magnets.
Yeah, if we have a magnetic coil and we bring a magnet with some speed, okay, to and fro, then we see that there is deflection in galvanometer. It means that we are getting electric current, or the potential is being generated. Such phenomena is called induction. Clear?
Sir,
Okay, sir.
So you guys are not revising, na? No revision? If you want do you want to get vision. So try to do redo. And do redo, then again redo. Then again redo. So it is a continuous process. If you will stop, you will lose the things. So what There was few more things. Mhm. We discussed about the magnetic fields, right? What is the right hand thumb rule?
So right hand thumb with the thumb will acting as the magnet field which goes like up to the direction towards upwards and the other fingers which is directing to the left side.
Okay. So what is right hand thumb rule, Jaslyn?
The current
I'm asking
uh,
to Jaslyn.
okay, so
You were confused.
as I woke up just now.
Madiha is coming after a long time. Madiha, most welcome. Madiha, are you there? Madiha, are you there? It seems like Jaslyn, you were speaking something.
So the right hand thumb rule is when we are holding a conductor in our right hand and we place thumb that
Yeah.
points towards the direction of current and the other fingers. If
Mhm.
we wrap it around the conductor, it shows the direction of the magnetic field
Yes.
lines.
Yes. So, Rizwan, will you improve your definition now? Madiha, what
Yes,
is what is right hand thumb rule? Madiha, what is right hand thumb rule? Madiha, what is right hand thumb rule?
If current carrying conductor is imagined to be held in your right hand,
Mm-hmm.
uh, then
Then what? If you will hold a current carrying wire in your right hand, you will get shock. That's it.
yes,
Oh, you will. So see, this is the situation of class. You guys don't revise now. So it says that if you hold a current carrying conductor in your right thumb, if the direction of current flowing coincides with your direction of thumb, then the curl, your finger, the rest of the finger, if you will curl, will give you the direction of magnetic field. Right? We did couple of numericals on this as well. But if you guys want revise, then it's difficult, na? So, Madiha, will you tell me what is Fleming's left-hand rule? What is Fleming's left-hand rule?
sir, I don't know. I just came.
You were not in the class last time?
No,
Okay, you were on leave.
yes,
Oh my gosh. So for the last two class, you were on leave or just last class?
just last class.
Okay, okay, no problem. So you didn't watch the recorded video?
I didn't receive it.
Oh. So for you, last time we played a video as well. So I think this time we can't do. Okay, so it says that you imaging your left hand, right? Left hand. So this was the experiment, right? So now you consider your 3 fingers of the left hand. What are those 3 fingers? Those 3 fingers are thumb, forefinger, and this center finger, okay, or middle finger. So it says that if this finger shows the direction of current, see, this is the direction of current, okay? The current is flowing through this metallic wire, and this is direction of current. Clear? And from north to south, oh, this is the north to south of direction of magnetic field. So that direction of current is here, this is, and magnetic field is there. So force on the conductor will be along the thumb. Clear, Madhya?
Yes.
Okay, we played a video last time. You were not here. I think Jonah, I don't know who is this Jonah. Jonah, hi. Are you first time? Okay.
Sir, it's Jesslyn, and I
Oh,
joined a different device because the other device, something is wrong with it.
okay, no problem. So you were last time when we were discussing about the Fleming left-hand rule. You were present in the last class, Jaslyn?
Yes, sir.
Okay. So the Fleming left-hand rule says, Madhya, you got the definition?
Yes, sir.
So now what happens? Either you change the direction of current. If you will change the direction of current, the direction of force will reverse. Reversing the direction of current, the direction of force will get reversed. Or if you will change the direction of magnetic field, the direction of force will get reversed. Clear? These were
Yes.
important points. So based on this, we have electric motors like pump motors, water pump, okay, or what? Fans, or what? Can you name some few devices?
So I guess washing machine
Yeah, their motor as well, no? Washing machine. Wow.
and wheel, car wheel.
Yeah. Car wheel
Uh,
if it is. So what is electric motor means? We are giving electrical energy and getting mechanical energy. If you are using the e-cars, okay, e-cars, then this, your example is true, okay?
yes, like Tesla cars.
Yeah. So these are the examples. So what is this principle called? This principle called principle of induction. Okay. So how a typical motor works, let me show you this animation. Because I know you guys remember the animations most. So this is the motor, right? This is north to south to the magnetic direction. Clear? And this is the direction of, from positive to negative is the direction of electric current. Clear? And you
Yes.
see that this is the axle. Along this coil is rotating. As we are giving it electric current, and it is going through this terminal. And from this, you will find that it is going to the wire and it is coming from this point. Return to the terminal. As the terminal is completing, there is a flux generation. You will find that this is not complete round shape. This is D shape, half brush. Okay, so it is half brushed. So how the force acts on it? To show that, I will again go to our main screen. This animation, keep this animation in mind, okay? So we are going again back to our main page. Okay, so this is our original motor. This is the diagram. So what happened? If the direction of magnetic field is in this direction, left hand rule, and current is in this direction, this graph, concentrate on this graph. So current, middle finger is inside, going inside, right? Because current is going like this. Clear? So this is inside, and this finger is along the direction of magnetic field, this side. So we see that force is like look in the downward direction, right? So the force will be in the downward direction. In the same way, the current is coming, the direction of on the side AB, current was from A to B. For the side CD, the current is from C to D. So direction of current is changed. So direction of force will be changed, right? Clear?
Yes, sir.
Those who were on last time we played that video, when we switch on the current, there was deflection in the magnetic, that conducting material, right? So what
Yes,
will
sir.
happen? What will happen? So because of this couple force, this will rotate along its axis, right? So how it will do? It will do like, see, this is like that. So it will go like that. So it will have one half rotation. So now it is perpendicular, parallel to the perpendicular to the surface. So now it has momentum, but there is no force. What will happen? Now again it will, till now this half this half d na, there is half d. This is the half d. So it will now connect to the another end of the metallic plate, right? And again it will get connected to the circuit and make another rotation. So it will be rotating around about its axle. So once the induction phenomena is generated, it will be having a rotation. Clear? Any doubt?
No, sir.
Also,
Understand the phenomena?
Yes, sir.
Anything to discuss about any confusion? No? Madiha, did you understand it?
Yes, sir.
What about Faz? Faz,
Yes, sir. Yes, sir.
what we were discussing, did you get this mechanism?
Yes,
Working
I got this
principle,
mechanism.
working principle. So kindly
It is
draw.
electrical.
Yeah, say.
Yes, sir.
You were saying something?
It is electrical energy into mechanical energy.
Okay. How it converts? What is the mechanism? How it will do that? There is proper mechanism. Okay.
Yes, sir.
How the force is being acted upon this loops, that depends on that. So we already demonstrated the direction of forces on both part, AB and CD part. So this is the diagram of it. If you want to make diagram, take the screenshot.
yes,
Okay, so this is such thing. Should I remove all these writings so it will be neat and clean? So these two, if you have to ask about the electric motor, but it is removed from NCERT books. Okay, now it is not the part of NCERT in the current syllabus. But I thought at least one of the utilization of Fleming's left-hand rule must be taught in the class. Clear?
Yes,
Okay,
sir.
sir.
Yes, sir.
Yes.
So there is
Yes, sir.
another. Sorry. Are you saying anything? It was Rizwan.
No, sir, I didn't say it.
So have you heard about generators?
Yes, sir.
So what's the mechanism of generators? How generators work?
It generates like electricity. Example, part like if motor, like if you spin a motor, like using a handle, you can make electricity. Yeah, you can convert that energy to electricity. Right, sir?
That's there
So
the
that's a
mechanical
generator.
energy into electrical energy, right?
Yes, sir.
So it is both way. From
Hmm.
electrical energy, the coil will run, or run better, we say rotate, or magnetic flux will change. Magnetic flux, how you will come to learn. The magnetic field line is this. Okay. Keep it simple, don't go because of electromagnetic induction. So electricity will come into the force if we are using generator. So see, this is not the part of NCRT. So kindly read yourself. This is the another part. Will you do? But I know, I know that how many of you will do the assignment. If I'll be doing here, you guys may be interested. We may do in the coming class next week. Okay, it will almost take half an hour. So in the next class, you will be doing electric generator. Meanwhile, you may study it. So that's it for the electric motor. Now we are coming back to one of the remaining topic of domestic circuits. So what do you mean by domestic circuits?
It is used in home.
Yeah, it is used in home to run our appliances, right? So how many terminals you need to have to run the domestic appliance? How many terminals? Means my question, have you saw this such type of socket?
Yes, sir.
What is it? What is the purpose of it?
This we put a plug inside and it charges our phone.
That's one of the
Uh,
best example, right? We
Yes, sir.
all look for it. Okay, where there is.
Yes.
So how many terminal we have in this socket? This is called socket.
Three or like
3, right? So basically, this is one. That is the green part. If you will color code, this is green part. This will be either red, right? Or black, or this will be either black or red, right? So
we
in
have
color,
five, right,
Okay,
sir?
sir.
We
black.
have five. We only use three.
These have the same purpose. Okay, these two have the same purpose.
So
Okay,
most of them nowadays don't have the up one. It only has
up
like
one.
two.
Yeah. So why? I'll come to that point. Okay.
Okay, sir.
If your mobile has metallic surface, na, so you will find this one. If it is not of metallic, the 2 is enough. Why will come after this introduction. So this is green. We connect this with earth, earthing or earth. to transfer the excess current to the ground. Okay, because we think that, or we know that the ground potential is minimum, right? So we pass on the extra current to the ground. Red is called live wire. So that's why we say don't touch the live wire. Okay. So you are touching the live wire, you may be in trouble. And we shouldn't touch the neutral wire as well, because we don't know which may harms natural wire. And this green is earth wire. Clear? So these are the three input devices. We take the input from it. Okay. So the another point is, we already studied in combination of resistance that we add appliance in our homes in series or in parallel. Series or in parallel. My question is, or parallel bus. My question is, we connect our devices in electrical circuit in homes in series or in parallel. Madhya,
Parallel.
parallel, right? I was knowing that you are able to answer it. Parallel. Okay. So how we will do that? There will be one live wire, LIVE, live wire, and another will be neutral wire, and the third one will be green one. Okay. So what we will do, we will take one wire from here and one wire from here, and we'll connect our mobile charger, and we will be happy. Another, if we want to add, then we will take another terminal and this. If we have metallic surfaces, the device has metallic surface. If metallic, okay, then we will do one connection with green as well. Clear? Clear?
Yes.
So this is the schematic diagram of, this is being shown in your NCERT book, right? And this is the NCERT diagram. So you may see that one is hot point, one is cold point, one is hot point, one is cold point. I won't say like one is live, one is neutral, one is live, one is neutral. And this green one is connected with the top port, right? So there was question, nowadays we find only two. So this is only if we have a metallic surface. So sometime you might have feel when you touch the metallic surface, you feel electric shock, right? Have you ever
Yes, sir.
Yes, sir.
Yes,
Not
sir.
just once, a lot of times, sir.
A lot of time. You are so
Yes.
naughty, na?
Yeah, it's
So if it is metallic surface, so metallic surface conduct electricity. Whenever there is some excess current or short circuits, so metallic surface conducts. But it is non-metallic fiber one, so these are not the good conductor of electricity. So we don't use that. So 2 port is enough. So that's called the earthing. Okay, we drain the excess current through that green wire to the earth. So this is the reason why we use only 3. That what is the earthing? This is the worth point to note down. The earth wire which has insulation of green color. These are the standard color codings. Okay, green, red, and yellow, black. If there are three colors, three wires, so you will always find green, red, and black. These three are universal standards. Otherwise, you may get yellow or different colors, but these are standards. So keep in mind. So if you are becoming engineer, keep in mind which wire is of which purpose. So green color is usually connected to a metal in the deep earth near our houses. We know all that. We used to dug some length and then we put the one wire. This is usually a safety measure, especially for those appliances that have metallic body. Clear? For example, electric press, toaster, table, fan, refrigerator, etc. The metallic body is connected to the earth wire, which provide a low resistance. This is a keyword, low resistance. Low resistance. Why this is low resistance? We know I is equal to V over R. Okay, a wire which has low resistance. So resistance, what is the definition of resistance, Jaslyn? Jaslyn, what is definition of resistance?
Sorry, sir.
What is definition of resistance? How
Sir,
you will
your voice is low.
how you will define the resistance? Now it's okay?
Resistance?
Huh,
Yes,
resistance.
sir. It is how do you say that?
It
The-
obstruct
the-
the flow of current, right?
It's against the flow of current.
Okay,
No.
okay,
Circuit.
right. That's true. If resistance has low resistance value, means that it will allow the current to pass in the easy go, right? So this is the thing. If this R is low, this current will be maximum. If this is minimum, this will be maximum. So
Yes, sir.
we use low resistance contacting part to the current. So if whatever current is, it will pass. It can allow the high value of current to pass. Okay.
Okay, sir.
This will behave like the free path. Okay, go ahead. Thus, it ensures that any leakage current, that's the leakage current, of to the metallic body of the appliance, keep its potential to the earth. We already know that earth has low potential or zero potential. So it minimizes, so current flows and it keeps that potential. And the user may not get severe electric shock. Okay. But you may get the light one, but not the severe one. Okay. This is the use or definition of earthing, right? So you may take the screenshot. So your question is answered. Rizwan, your question is answered now.
Yes, sir. Thank you.
Okay. Madiha. Faz.
Yes.
Yes, sir.
Any confusion? Any doubt?
No, sir.
No, sir. So I will ask you one thing. This is the low resistance and high resistance we discuss. What is the open circuit? CIRCUIT, open circuit. What do we mean by open circuit?
When the wire is broken,
When the wire,
When the circuit is open, I mean the electricity is not passing or it's been interrupted or opened.
Open, right?
It's not passing. I mean, it's not flowing the electricity. Yes.
Okay. What is short?
Short circuit.
Yeah.
Short circuit. I think the sudden flow of electricity that the wire cannot handle, and the wire gets burst,
Yeah.
making the wire useless.
Okay. So let me have some space. I'm not good at board work. Okay. I write here and there, and then I look up for a space. So short circuit, just let me free some space. Okay, I'll draw over here. So tell me, I have a situation. Okay, this is a bulb, and this is a battery. This is a switch. Okay, and I have connected the switch. Switch is on. This bulb is glowing, right? This bulb is glowing. Okay, this bulb is glowing. Switch is on and bulb is glowing, right? Now I'm doing that. I'm connecting these two terminals over here, and current is flowing like this. So what will happen? What will happen? This is the short circuit, right? What will happen?
Sir, can you say the question again?
Okay, so this was the situation. A bulb was glowing. So finally what I did, I bring a wire and I connected it to these two terminals. What will happen?
So it would have excessive current.
So it won't be having,
It won't pass to bulb.
it
I
won't
said it would
pass to
have
bulb.
more resistance.
Okay, so the current will feel that, sorry, this is not the direction. The current will feel that this is the shortest path for me to complete the circuit. Okay, so it will forget to go about this line. Okay, it won't go around this line, and it will jump to this line. Okay, because it's the short circuit. Short is the short. Okay, so
I said
it
the
will
bulb
just,
will not glow.
so it will go like this, and then it will be a explosion. Okay, so we do sometime in our daily life. Ispan might have done it. We used to, we take current from, mm, just we used to take two wires from here. Okay, two wires from here, and by mistake or by intention, you may
It
feel
touches.
uh, it crosses, it touches each other. So what happens? So,
Short
so all of your
spark.
apparatus you might have feel that gets off, right?
Yeah.
With a spark or something, you may get some
Mhm.
damages. Why this damage happens? If there is no fuse, if there is no fuse, or that some smart devices, all current will go through this way, and there will be enormous heat will get generated. That I square RT. Power is what? Heat, we already given the formula for heat, right? So then it is I square R into T. So in this case, if the circuit is short, so current will increase, right? And then heat will be generated. Or you may write in the, if you will revise power V is equal to IT, or yes. So basically this will happen. Enormous heat will generate, and it might catch the fire. So that's why play with electricity, but play, but keep the physics in mind. Clear? Clear or not?
Yes, sir.
Okay, so next time when you do anything, keep the physics in mind. So can we move further? I think we don't have much to discuss. So now you have these questions. Question 1 and question 2, question 3, leave it, it's bit numerical based. So question 1 and question 2. Jaslyn, answer the question, answered the question 1. And Rizwan, you think of question 3.
Okay, sir.
Sir, can you zoom?
Okay, okay.
So for me, question 3.
Yeah. So it's okay, Jaslyn?
Yes, sir.
Okay.
Hmm.
That's good. Name 2 safety measures commonly used in electric circuit and appliance.
Using the earthing wire,
Yeah,
it can prevent electric shocks.
yeah, that's good.
And
Faz, will you tell the second one other than earthing? And Madiha, be ready.
Yes, sir, you need the second one.
Sorry.
Can you repeat what you said?
Question number 1. Jaslyn answered one part, that earthing. Now I'm asking from you what is the next one, the other one, the safety
Yes.
device.
Name 2 safety measures.
I mentioned in this lecture only, right?
Yes, sir. Once again, I will.
No problem. Madiha, now your turn. Your turn.
Sir,
Yes, sir.
Question number 1.
electric fuse.
Faz, Madiha, okay. Madiha, question number 2. Sorry,
Okay.
leave the question number 2. Question number 1. What are 2 safety devices we use in our appliance?
Electric fuse and
Electric fuse and
proper
electric fuse and that 2 already being named over here. Okay. So what is those devices? Okay, Rizwan, question number 3.
So,
Yes.
to avoid overloading, connecting too many like devices or applications to is like a single circuit. So it will take large amount of electricity, making the circuit heat up, the main circuit. So it can melt and yeah, it will not work. It will overload.
Yes, basically it happens in extreme winter when we use geysers or heaters, or extreme summer when we use
Too many
cooling
AC.
devices. Okay,
Yeah.
so in those situations, the overloading or overshading, we also say, na, it happens.
To avoid it, we use fuses. Fuse or
Fuses?
earthing. Fuse or earthing.
Ah,
Right?
yes, yes. And what is the combination or fuses are made up of? Fuses are made up of?
Resistance.
No, no, no. I'm asking about materials.
I know. It's like it has a copper wire, thin copper wire inside, right?
No, no, no. You can't use copper. You can't use copper.
So when it has like a electric circuit or short circuit, it get cuts down.
Yeah, it
I
melts
saw.
down. Okay, it
Yeah, it
melts down.
melts, so it will
Yeah,
cut.
yeah, melts down.
It's copper or what?
We use copper, we can use, okay, but using copper is not that much safe.
Uh,
We use
so my parents use copper.
so it's not that much safe. Okay, if you will use tungsten, why not you are using tungsten? So
I
that
don't
has
know.
high melting point, na? It will take
Mm.
time to melt. So actually we use lead or some tin, okay, that alloy of lead and tin. So it will melt easily. Clear?
Mm. Yes, sir.
So when does an short circuit occur? So we already have an question and answer it. Now you have the surprise question number 3. You send me answer one by one in inbox. Okay. Write A is equal to P, B is equal to Q, C is equal to R, whatever it is. Everyone in my chat box. Sorry, I didn't get any response. I didn't get any. Yeah, first response is from this one, A to electric potential. Right. You make all the list, na, A, B, C, D, and then send.
Oh, okay, sir.
That's why I'm asking the chat box now. Otherwise, you will be saying, some other will be listening, and then you all will copy paste. So this is check how you are active in the class. Right. So this one now you think for the next question. You think for the next question. I only got response from Rizwan. Okay. What you guys are doing?
Sir, I sent.
You too? Okay, Jasleen response.
Say send all.
Okay, good. So you send me answers.
All of them.
Where is Jasleen, Madiha? Okay, okay, okay. So then Jasleen. Jasleen, your A is not true. Okay. B is electric current. R, that's true. And D is okay. That's also true. You just interchanges the electric potential and electric power, right? So you relook Madiha A electric. No, what Madiha, your first A option is not true. D is true. B, you still Madiha has also exchanged. Well, what about I got only two response, three response. One,
I sent. Oh yes.
three. Yeah, huh. I got only three response. But here we have four students, right? So what
Sir,
about
now
the
only
first
three
one?
students.
Huh?
In class now only three students
Faiz was also there, na?
left. I guess.
Oh my god. So did you? So I'm saying that those. What is difference between electric potential and power? Power is work done per unit time. So where there is a discussion of time, that is the work done. Okay. Clear, Madhya? Where
Yes.
power is work done per unit time. So it is per unit time. And electric potential is just the work done. So keep in mind, you and Jasleen.
Okay, sir.
Okay, okay. So these are the minute change differences that you may lose your marks. And this is the HOTS. Somewhere in board term 2016. Alpha particle state whether an alpha particle will experience any force in magnetic field or not. So this is the definition of force you will study in class 11th or 12th. This is charge and this is V cross B, where V is the velocity and B is the magnetic field, F is the force, right? So based on this, you answer me the question. Will you write me in the chat box or can you think of it or not?
I don't know, sir.
I know that. This is the different question. So see, magnetic field only act when this is the velocity. Let me write it. Velocity. This is magnetic field. Magnetic field. This is charge, right? Alpha particle is a charge particle. So this is charge. And this is force. Okay. So if velocity is zero, like that, at rest, so the force will be zero. Clear? Jasleen, is clear?
Okay, sir.
When magnetic field parallel to the field lines, the cross product, this is the cross product. Okay, so this may be written as VB sine theta. When these two are parallels, like this is V, and this is V. This is V. So these two are parallel, right? So Madhya, tell me what will be the angle between V and B? Jaslyn, what will be the angle between V and 2? When two lines are lying across along each other, so what will be the angle between these two lines?
0 degree.
So sine 0 is how much? Madhya, sine 0? Rizwan, sine 0?
0.
So this will turn to 0. This is also 0, right? This will also 0, right? Now it's saying perpendicular to each other. Perpendicular matlab this is B and this is V and this is 90 degree. So Madhya, sine 90 is equal to how much? The theta between V and B is 90 degree. Madhya, sine 90?
Yes, sir.
What is the value of sine 90?
Zero.
Sine 90 0. What is Jaslyn, sine 90? Jaslyn, what is value of sine 90?
Root 3 by 2.
Okay. Rizwan, what is value of sine 90?
1.
1. So Rizwan is the winner for the day. Okay, so it's 1. So VB into 1 will be VB. So it moves. So the force will be here non-zero, right? It will be equal to VB and this is non-zero. So alpha particles may force in these cases. So in this case, it will experience forces. So Jaslyn or Madhya, kindly go and look the values of trigonometric ratios, right?
Okay, sir.
Okay, so we are going to end the class for the day. Okay, and this way the chapter is over. If we will study the generator, that will be in addition. Okay. So
Okay,
see
sir.
you next week. Bye. Take care.
Thank